a very important subject. And
Yeah.
mm, although although the basic reason to take me on board to cover the topic of nutrition was to talk about the health effects of nutrition,
Mm-hmm.
basically. Me being a doctor, I can talk about nutrition related disorders for like days. And the topic will not end. If you have to do justice with this topic, you have to days, talk for days.
Yes.
But I always move in a very systematic way. So I found it very difficult to just hop on to the nutritional disorders without like getting a rapport and getting understanding of the topic myself and delivering the basics from my perspective. So most of the people, maybe they already have studied the topic of nutrition elsewhere or from some other tutor or teacher, whatever you call. But I tried to cover the basics for today's lecture because this is a very important series, and my style of teaching does not allow me to go and to hop on to some subtopic without covering the basics of such an important topic. That is why it's introduction to nutrition and healthy foods. We will not discuss nutritional related disorders. We will kind of touch many minor things. We will just keep touching them, but we will not go into the detail of the nutrition related disorders in today's class. But this is gonna be another fantastic lecture series for those who really want to learn the same old topics in a new, interesting way. Nutrition has been taught in almost every university all around the world, but I will try my best to do justice with this most important topic. So I would want to know whether everyone can see my screen or not, so that I can move on. I was
We
having
can
issues
see
with.
the screen, Dr. Omer, but I would, if you don't
Thank
mind,
you so much, sir. Thank you
I
so
would
much.
also recommend that you hit
Okay.
F5 on your system or start the
Oh yeah, I
oh,
am gonna. Yeah, yeah.
okay,
I
okay,
am
all
gonna
right.
hit. I am gonna move into the slideshow position. Yeah.
Wonderful.
I was just thinking about going into the slideshow.
Yeah, yeah.
Okay, so what we are gonna talk about today is introduction to the nutrition and healthy foods. I hope everyone is on board. So we are gonna start. So this is a very important subject. This is very, very important. Just like environmental health series, there was also a very important series. And at the end of those four lecture series, I answered for like 50 minutes straight. I tried my best to answer every single one of your questions. And this is also going to be a very interesting series for those who want to learn the nutritional aspect of our lives in a new and interesting way. So, nutrition, dietary habits, and public health. This is our main topic, and today's subtopic is Introduction to Nutrition and Healthy Foods. So, this is going to be introduction all or long. So, I'm resident orthopedic surgeon in Benazir Bhutto Teaching Hospital, Rawalpindi Medical University, Pakistan. So, the learning objectives for today's class are introduction, then basic definitions, the process of nutrition, what are foods and nutrients, then five various classification systems of foods being run in the world, then various types of nutrients, micro and macronutrients, then understanding the concept of balanced diet, then we will just slightly touch the concept of relationship between nutrition and health. As we know, we have to move on towards the nutritional disorders and the relationship between the nutrition and public health. But in my system of teaching, in my way of teaching, I can never move on to the subtopic without going into the basics of the topic itself. So that's why we are gonna start our this nutrition lecture series with the understanding of the introduction and introductory topics. So we are what we eat. That is the introduction of our this new lecture series. We are what we eat. At the most basic level, the concept of having a good nutrition means eating a regular, balanced diet, as nutrition is the thing which keeps our body's systems running optimally all day long, or you can say 24 by 7. The foods we eat supply our body with the needed nutrients to maintain our brain, muscles, bones, nerves, skin, blood circulation, and all the organ systems, as well as immune protect from illnesses and many diet-related disorders. We will touch these subjects in today's class as well, but we will go into the details of nutrition related disorders and illnesses in our next lecture series. So, important definition. We cannot move forward without getting to know the basic definitions of the topic we are going to talk today. So, nutrition is the process of taking in food and converting it into energy and other vital nutrients required for life. In the process of nutrition, organisms utilize nutrients or nutrition, the assimilation by living organisms of food materials that enable them to grow, maintain themselves, and reproduce. Nutrients. Nutrients are the substances essential for growth, maintenance, function, and reproduction of cell or an organism. The absence or deficiency of any of these may result in poor health or disease of organism. So basically, the food we eat, what are we getting from our food are the nutrients. We are eating a burger, a pizza, a bread. We are eating an egg. We are eating some apple. These are the nutrients from the food we are eating for our benefit. So the nutrients are the substances essential for growth, maintenance, function, and reproduction of a cell or an organism. If an organism is a unicellular organism, just like bacteria or a virus or fungi or any other unicellular organism, the cell depicts whole organism. So even if an organism is a unicellular microorganism, it needs nutrients. And the same case goes with the organisms who are large, who are multicellular, like human beings, like mammals, like insects, like fish, and many other organisms like birds. So all of these animals, all of these birds, all of these fish, all of even plants, they are taking in nutrients which are essential for their growth, maintenance, function, and reproduction as well. The absence or deficiency of any of these may result in poor health or disease of organism. Then undernutrition. Undernutrition is defined as low weight for age, low height for age, and low weight for height in children or adolescents. Undernutrition is defined as low weight for age, low height for age, and low weight for height in children or adolescents. That chronic energy deficiency, the conditions of being underweight among adults. So if the problem is in children or adolescents, we call it undernutrition. And if the same problem is coming in adults, negative energy balance, BMI value of less than 8.5 indicates CED in adults. If an adult who's having a BMI of 18.5, or some books even say a BMI of less than 18, then you can label that person as having a chronic energy deficiency problem. Because if a person is having BMI less than 18, then that's not normal, no matter how thin lean he is. He or she should be above BMI level of 18.5. Then kilocalorie. It is the amount of heat required to raise the temperature of 1 liter of water by 1 degree Celsius. So basically, if you take 1 liter of water and you give that 1 liter of water heat, so the amount of heat required to increase the temperature of water by 1 degree Celsius, we're talking about pure water without impurities, by 1 degree Celsius, the amount of heat required has been standardized all over the world. And that heat is measured in kilocalories. And we call that heat constant to be a 1 kilocalorie. And whenever we use the word kilo, it means thousand. So it equals to the 1,000 calories. Body mass index. What is BMI? It is a ratio of weight for height, which is often used to estimate body fat of an individual. It is obtained by dividing the weight in kg by square of height in meters. Most of you already know what is BMI. Will not go into the details. So metabolism, the sum of all the chemical and physical changes that take place within the body that enables its continued growth and functioning, is called metabolism. And nutritional security, it is the physical, economic, and social access to a utilization of an appropriate balanced diet, safe drinking water, environmental hygiene, and primary health care for all. So basically, what is nutritional security? It is the physical, economic, and social access to and a utilization of an appropriate balanced diet, safe drinking water, environmental hygiene, and primary health care for all. Then, diet. What is diet? Diet is a sum of food consumed by a person or any other organism. So, whatever we are eating, the sum of the food intake that we are taking is our diet. Whether it's bread, whether it's rice, whether it's beans, whether it's whatever, whether we are taking some fruits, whether we're taking some vegetables, whether even we are taking some sugary drink, whatever. So diet is the sum of food consumed by a person or any other organism. A balanced diet. It is a food intake that includes all of the dietary and nutrient needs of the organism in correct proportions. You may be taking a diet full of carbohydrates, and you may be missing out on very important vitamins and minerals. You may get fat, but inside you will be very weak. Some of your enzyme systems will not be working properly. Some of your hormones will not be working properly. Some of your body organs will not be functioning optimally. Sometimes your brain will not be functioning optimally. Sometimes your liver will not be functioning properly, and you will be thinking, "What is wrong with me? Why I feel sick all the time?" You may be anemic because the iron content of your diet is very low. So you may be taking very high calorie diet, but still you might get sick. Why? Because you're not taking a balanced diet. So it is a food intake that includes all the dietary and nutrient needs of the organism in the correct proportions. Whatever we take, we have to take it in the correct proportions. That is the most important word in balanced diet concept. Therapeutic diet, it is a hospital definition. It is a hospitalized diet or some special diet for some special needs of a special patient. It is a modification of food, either in consistency, preparation, or nutrients to meet the special nutritional needs of a person suffering from a particular disease or condition. So if a person is suffering from a particular disease or condition, for example, there are some alcoholics we receive in our hospitals who consume too much of alcohol, and due to the intake of too much of alcohol, they develop a deficiency of a specific vitamin called vitamin B1 or thiamine or thiamine, whatever you call it. So they are having neuropathic symptoms, they are having delusions, they are talking abnormal. They sometimes they can't see even. There is one vitamin that if you get deficient in, you stop seeing properly. So the neuropathic symptoms start. So what do we do? We start the therapeutic regimens of such patients. This is just one example. There are many other examples as well. We give him diets rich in vitamin B1. We stop alcohol as well because the alcohol stops the digestion and absorption of vitamin B1. But we decrease, at least decrease the intake of alcohol, and but we always try to stop it. But if we can't stop it, or it is very harmful for the patient to stop it altogether, we decrease it drastically. We decrease the intake of alcohol, and we give therapeutic doses of vitamin B1 to that patient, or we give vitamin B complex, which contains all of the vitamin essential vitamins. So the patient starts getting better within days of taking medication. So that is the concept of therapeutic diet. Then the process of nutrition. So this section will elaborate the entire process of nutrition and its related subtopics. So what is the process of nutrition? So nutrition starts with the ingestion, the process in which food is taken inside the body. This ingested food is then digested. So the nutrition of any organism, any person starts when he ingests the food available on his table. So the process in which food is taken inside the body, this ingested food is then digested. So that process is called ingestion. So that is the start of our nutritional journey. Then there is the process of digestion, the process during which complex, non-diffusible, and non-absorbable food substances are converted into simple, diffusible, and absorbable substances by the enzymatic action in our stomach and intestines. So our stomach and our intestines digest the food we take, we ingest, and make it simple, diffusible, and absorbable into the bloodstreams. Then absorption, the process in which the simple substances get diffused into the blood. Thus, absorbed food is now carried to each and every tissue cell of the body where it is assimilated. Then assimilation, the process by which the protoplasm is synthesized into each cell of the body by utilizing simple food substances. Then egestion, process of elimination of indigestible remains of the food from the alimentary canal. Defecation or evacuation, we also call it defecation. So whatever the food we take, part of it is useful and part of it cannot be digested. And sometimes it also contains harmful substances because we are not it is not in our benefit to take 100% refined food. We need to take raw veg and fiber as well, which cannot be digested, and that should be the part of our diet. We will talk about it later. But the process of the elimination of the indigestible remains of the food from the alimentary canal, defecation or evacuation, this process is called ingestion. And here the process of nutrition ends. So foods, various classification of food. So what is food? Food can be defined as anything that can be solid, semi-solid, or liquid, which when swallowed, digested, and assimilated in the body proves useful to it. These substances not only keep the person alive, but also provide energy used for growth and development, regulate body processes, and protect the body from disease. There are 5 different food groups according to Indian Council of Medical Research, which include cereals, grains and products, pulses and legumes, milk and meat products, fruits and vegetables, fats and sugars. So we all know the names, and we can even imagine what cereals or grains look like, what are pulses and legumes, what is milk and meat products, fruits and vegetables, and fats and sugar. So basically, This is what these things look like. Cereals and grain on the left, then pulse and legumes in the middle, fruits and vegetables. We are familiar with these things. Then fats. Now, there are two kinds of fats. One are animal-derived fats, and one are plant origin fats. So the fats we get from avocados or the cooking oils we use, most of them, more than 90% of them are from plant origin. Then the fats we get from the nuts are also from plant origin, but the dairy fats such as butters and the fats we get from fish and meats, they are animal source fats, and chocolate is also a plant source fat. Then there are sugars. The sugars are of different types. Then there is white sugar, there is jaggery, there is brown sugar, there is refined sugar, there is unrefined sugar. There are multiple types of sugar which we use in confectionaries, bakeries, day-to-day dishes that our moms make for us. So we do intake sugars a lot. Then there are classification systems of food. We will not discuss all of the classification systems of foods in this class, but we will discuss the important classification systems of food. But by name, we should know what are the classification systems of food. So first of all, by chemical nature, carbohydrates, proteins, fats, vitamins, minerals, dietary fibers, and water. These are the by chemical nature. Then by functions in the body, they are energy giving, body building, and protective. Then there are biochemical properties. Some are organic, some are inorganic. The elements, the minerals that we are consuming are inorganic. The carbohydrates, the fats, the proteins, and vitamins, they are mostly organic substances, but that we are using are inorganic substances. Then there is another classification, and the classification by mass. By mass means any food that we need for our body in greater mass, in greater quantity. That food is called macronutrients. Then there are foods which we need in very small quantities. Some foods in milligrams, and some foods in micrograms, or some in even nanograms as well. Then those nutrients are called micronutrients. Then by origin, there are some plant foods or animal foods. And then by nutritive value, there are 12 categories. We will not go into the complete classification system of foods because this is not more about the nutrition, but we have to just cover the basics of the nutrition so that we can move to our main topic in our next lecture series, and that is nutritional disorders and nutrition related public health problems. So the classification according to chemical nature. According to chemical nature, food is classified into 7 subtypes. We will also discuss these 7 subtypes later as well. But according to chemical nature, food is classified into 7 subtypes as described in the image. So carbohydrates. Carbohydrates are the sugars and starches found in fruits, grains, vegetables, and milk products. Though often maligned in trendy diets, carbohydrates are important as a healthy diet. Then there are proteins. We already know proteins make up the building blocks of organs, muscles, skins, and hormones. Your body needs proteins to maintain and repair tissues. Then there are fats. Fats are a source of enormous energy. Temperature regulation and vitamin absorption. Fats can be found in various foods, and there is fiber. Then we are talking about minerals, which are basically the elements such as zinc, selenium, magnesium, copper, iron, calcium, phosphorus. Then these minerals play a very important role in the regulation of many metabolic processes in our body. There are many enzymes, there are many hormones, which also contains one or two atoms of these minerals as well to function properly. Then there are vitamins. We already know what the importance of vitamins. We will discuss about the vitamins later. Then there is water. So basically, according to the chemical nature, food is classified into 7 subtypes. These are also the components of balanced diet that we will discuss later in this lecture. So the balanced diet also consists of these 7 components, but in correct proportions. You cannot take carbohydrates more and proteins less, and vice versa. We'll talk about the balanced diet later. So Then classification of foods according to their function in the body. So, according to their function in the body, there are three types of foods. The energy. I am moving fast. I am moving fast because this is a little bit longer lecture. This is we have to cover too many slides, and that is why I'm moving a little bit fast. And I am also expecting that many of these things are basics, and most of you already know about the basics. That's why I'm moving fast. And when I will think that there is something new to learn, I will control my speed. But right now, I'm moving fast because we have to cover too many things today. So, classification of foods also according to their function in the body. So there are energy giving foods. The carbohydrates, fats, and proteins are considered a calorie nutrient so that the body can perform the necessary function. For example, rice, bread, potato, sugars, butter, and ghee, etc. These are the energy giving foods. Then there are bodybuilding foods. So bodybuilding foods such as proteins, fats, and complex carbohydrates are also called as bodybuilding foods. They are the nutrients that form the body tissue. Fish, meat, chicken, eggs, pulses, nuts, and milk are some of the bodybuilding foods. Then there are protective foods. Vitamins and minerals are nutrients that function to regulate body processes. So basically, vitamins and minerals do not give us energy directly. They do not build our muscle mass. But what are they doing? They are protecting us from many different problems that occur in our metabolism, day-to-day metabolism. Vitamins and minerals are the nutrients that function to regulate body processes. Fruits and vegetables contain enormous quantity of such substances. These foods protect us from various diseases as well. So, classification according to body requirements. So, there are macronutrients. Macronutrients are those nutrients which are needed in greater mass or greater quantities. Macronutrients are required in large quantities daily. Carbohydrates, proteins, and fats are macronutrients. They are the basis of any diet. We can even put water into the macronutrients as well because we consume a lot of water as well. And we are basically 70% water. So but basically, there are four things that we are running on: the carbohydrates, the proteins, the fats, and the water. And then there are micronutrients. There are some examples of micronutrients in this diagram. The micronutrients are needed in small quantities, usually in amounts less than milligrams per day. It may be micrograms as well. Their main function is regulation of metabolism and energy process. They do not give us energy directly. They do not yield energy on hydrolysis or breakdown. Just like fats, carbohydrates, or proteins, when they are digested and assimilated, they directly yield energy upon the hydrolysis of their molecules. But that is not the case with micronutrients. Micronutrients are needed in small quantities, but their main function is regulation of metabolism and energy processes. These include vitamins and minerals. We will discuss macro and macro concept later as well. Then, according to its origin, there are animal proteins and plant proteins. On the left of the image, there are animal source proteins just such as eggs, the meat of the fish, the meat of any the red meat of any mammal, then such as beef or mutton. Then there is cheese as well. And then on the right side, there are plant proteins. We can see broccoli, and we can see some roots as well, and we can also see mushrooms, etc. So basically, there are two types of proteins. One are the plant source proteins, and one are the animal source proteins. And we can classify foods according to their origin as well. Then the nutrients. So what are the nutrients and what is their role? We will not go into the extensive details of the nutrients because this is my understanding that you already know about the basics of nutrition as well. So we will just keep touching all of the seven basics nutrients that are needed for the balanced diet. So nutrients, the substances which are present in the food that we consume, which are important for the upkeep of vital functions of our body, are called the nutrients. The substances which are present in the food that we consume, which are important for the upkeep of vital functions of our body, are called the nutrients. According to WHO, these nutrients must come from food and they are vital for disease prevention, growth, and good health. As already discussed, nutrients are further subdivided into macro or micronutrients, depending upon the need of the body on daily basis. So, what are the nutrients? We already know there are macronutrients and micronutrients, carbohydrate, proteins, fats, and water. There are macronutrients, and micronutrients include vitamins and minerals. Then we come to the first macronutrient, that is carbohydrates. So carbohydrates are main source of energy for our bodies, providing 4 kilocalorie per gram of carbohydrates when it's digested in our body. Carbohydrates consist of carbon, hydrogen, and oxygen. The general structure of carbs is CH2O N in ratio of 1 to 1. So this is the general structure of carbohydrates. The building blocks of all carbohydrates are single sugar molecules called monosaccharides. So monosaccharides may contain a keto group or they may contain an aldehyde group as well. But the basic building blocks of all carbohydrates are single sugar molecules called monosaccharides. So there are examples in the image attached. The monosaccharides that we encounter on our daily basis that we use in our body is glucose, fructose, and galactose. Galactose is present in milk, and fructose is present in enormous quantities in honey. Glucose is basically the breakdown product of sucrose that we consume on daily basis in the form of sugar. So we do not consume the glucose directly. We consume sucrose in the form of sugar, but the glucose is the basic product of sucrose, which is consumed by the body. So this is the most important monosaccharide in the life of humans as well as mammals. So single sugar molecule is a monosaccharide. Then there is disaccharides, which are maltose, sucrose, and lactose. These contains two sugar molecules. Then there are polysaccharides. I'm sorry for yawning. Basically, I'm restless. I had to work very hard for this class just to shorten the class. So disaccharide is are maltose, sucrose, and lactose. Then there are polysaccharides, which are starch, glycogen, and cellulose. So polysaccharides consist of chains and chains of sugar molecules. Basically, polysaccharide contains chains and chains of sugar molecules joined together. They may be chains of glucose and galactose linked together in cis-frank positions. They may be chains and chains of glucose molecules with themselves, or glucose, or mannose, glucose, or fructose, whatever. So basically, we will not go into the details of what forms the starch, what forms the glycogen. There are minor differences, but these are the chains and chains of monosaccharide sugar molecules linked together. Daily requirement, sources, and functions of carbohydrates. We will just touch these things. We will not go into the details. So the daily requirements, carbohydrates intake should be in the range of 50% to 70% out of total energy intake. That corresponds to something like 300 to 350 grams to 500 grams in a 70 or 80 kilogram adult person. So carbohydrates intake should be in range of 50% to 70% out of total energy intake for adults and 40% to 60% for children. So sources of carbohydrates are all sugars, jaggery, honey, whole grains such as wheat and rice, cereals, fruits such as dates, guava, apple, many of the fruits, all of these contains carbohydrates. Then milk contains carbohydrates, roots and tubers such as potatoes and beetroots, etc. They also contain rich sources of carbohydrates as well. Potatoes are full of starch. And the functions of the carbohydrates are they are the most abundant dietary source of energy for all living beings. In stored form, they also act as energy source in the body. So the first and foremost energy source in the body are carbohydrates. Our liver stores carbohydrates. So the first and foremost energy source in the body is glycogen breakdown, and glycogen breakdown yields glucose. So, and glycogen is a carbohydrate. So basically, whenever we start doing exercise or we start doing some heavy activity, our body starts using the stored carbohydrates that are present in the liver. They act as intermediates in the synthesis of fats and proteins as well, are the main energy source for brain. Yeah, our brain functions on carbohydrates. Our brain always needs carbohydrates for the better functioning. Glucose uh, crosses the blood-brain barrier. What is blood-brain barrier? It's basically a barrier which is present between the all of the body's blood and the brain's blood, and it is very important safety mechanism for the brain. I cannot go into the details of what a blood-brain barrier is, but basically glucose can go through the blood-brain barrier, and it is the basic food of the neuronal tissues. That is why when we are doing some brain work, we are brainstorming, we get cravings for sweet things and sugars as well, because sugars contain carbohydrates. So basically, our brain needs glucose, which is a monosaccharide carbohydrate, and so we start getting cravings for the sugars. And from the structural framework, form the structural framework of RNA and DNA molecules. And then we come to the proteins. So I have shown the sources of proteins in this image as well. Proteins are the essential constituents of the diet. Proteins are made up of amino acids. Amino acids are needed for replacement and growth of the body parts. Proteins are the building blocks of proteins are amino acids. So amino acids are classified as essential and non-essential amino acids. The essential amino acids cannot be synthesized by the body and must be taken through foods, whereas non-essential amino acids can be synthesized in the body. So the daily requirements of the proteins are Indian Council of Medical Research recommends at least, this is least value, at least 1 gram of protein per kg of body weight for adults. The amount of protein should be increased for children, pregnant and lactating mothers by 1.5 to 2 grams per kg body weight. And if a person is having a surgery, has undergone a surgery, or has is having some injuries due to road traffic accidents or some war-related injuries, or having some amputation, etc., the amount of protein should be increased to 2.5 to 3 grams as well in such people. So basically, if we are living a normal life with a sedentary lifestyle, we need 1 gram of protein on daily basis. But if we are having some heavy strenuous activity on day-to-day basis, such as laborers, or if we are in growing age, such as children, or if we are in hyperphysiological states, such as pregnant women or lactating mothers, then the amount of protein needed by the body goes up to 1.5 to 2 grams per kg body weight. And if a person has undergone a major surgery, or has gone some severe injury, then even 2.5 to 3 grams daily requirement of proteins as well. The functions of proteins, the body is 15 to 20% proteins and 75 to 80% muscle, of which the 75 to 80% of the proteins is muscle. One of the causes of hair loss, muscle weakness, and unstable mood can be protein deficiencies as well. Protein helps in synthesis of enzymes, immunoglobulins, plasma proteins, and hormones in the body. Protein helps in growth and repair of body tissues. Proteins are secondary source of energy during deficiency of carbohydrates and fats. It also provides 4 kilocalorie per gram. Protein also helps in forming hemoglobin. Proteins help in antibody formation. Majority of the enzymes and hormones are proteins. So basically, proteins also play a very important role in our bodies. Most of the enzymes and hormones are proteins in nature. It also helps in antibody formation in the body. It also helps in forming hemoglobin. Hemoglobin is basically a complex protein as well. So all of these functions of protein make it an essential nutrient in our diet. Then there are some other functions of proteins such as transport proteins, transferrin hemoglobin, which transfers iron, and transferrin, which transfers uh, iron in the body. And then there is hemoglobin, which contains an iron molecule, and it transfers oxygen in the body. And then there is central nervous system proteins such as laminin, nerve growth factors, etc., which play a crucial role in the development of central nervous system. Then wound healing, regeneration, energy, and satiation. If a person is having severe injuries, he needs to take proteins for the better wound healing. If he stops eating proteins, no matter how much wealthy he is, no matter even if he's admitted in Harvard medical school and related hospitals, even if it is the person is admitted in Mayo Clinic, if the person does not take proteins, the wound will not heal. So basically, the fluid balance of the body is also maintained by the blood proteins such as albumin, lactalbumin, etc. Then acid-base regulation is also regulated by hemoglobin and albumin, etc. Then there are important hormones such as thyroid hormone, thyroid stimulating. No, thyroid hormone is not a protein; it's a steroid hormone. But other hormones such as insulin and growth hormones, etc. They are basically proteins, and there are enzymes such as pepsin, amylases. These are proteins. Then there are lysozymes, antibodies. So proteins are, they are taking part in every important function of our body. Then we come to the fats. So fats are concentrated source of energy containing carbon, hydrogen, and oxygen. Fats are solid up to 20 degrees Celsius, and if they are liquid at that temperature, they are called oils. They are insoluble in water and soluble in chloroform, petrol, and ether. So basically, fats are hydrophobic molecules. They're not hydrophilic molecules, and they do not get dissolved in water. They get dissolved in hydrophobic solvents, such as chloroform, petrol, and ether. All of these are hydrophobic solvents. These solvents themselves do not get mixed with water, do not get dissolved in water. So basically, fats also get mixed in the hydrophobic solvents and not the vice versa. Fat is deposited as adipose tissue in the body and performs essential functions in the body, such as heat production. Thermoregulation of body is also done with the help of fat tissue. Fats are composed of fatty acids and contain oxygen, carbon, and hydrogen. Fat tissue is the main energy reserves of the body in case of extremely low calorie diet intake. So fats are classified into simple lipids such as triglyceride. Then there are compound lipids or complex lipids such as phospholipids. Then there are derived lipids which our own body makes from uh, available substances such as cholesterol and vitamin D, such as cholecalciferol, which is also made from cholesterol. So basically, our body makes cholesterol, and then cholesterol is used to make other fat soluble vitamins as well, such as vitamin D. Fats are classified into two types: saturated fat and unsaturated fat. The saturated fat, basically, these have full number of hydrogen atoms. They do not have double or triple bonds, so they do not have vacant positions for the hydrogen. These are from animal sources. Examples are butter, ghee, and vegetable oils. So basically, the more the saturated any fat gets, the more uh, solid like it becomes. So the most saturated fats are solids at room temperatures. So that is why saturated fats are solids and unsaturated fats mostly are liquids at room temperatures. So these contains one, two, or more double bonds of fatty acids, and there are sometimes triple bonds of fatty acids as well. So there are vacant positions for hydrogen atoms in unsaturated fats. These are extracted mainly from vegetable sources. Example are groundnut oil, soybean oil, sunflower oil, canola oil, etc. So daily requirements are 15 to 20% of total calorie requirement should be from fat. This is about 45 to 75 grams per day of fat. If you eat 2,000 calories a day. Into the details, as you people already know, fats are basically a rich source of energy. They provide 9 kilocalories per gram of fat when it's digested and assimilated in our body. The fats improve the palatability of food. They give the flavor, aroma, and taste to the foods. It supports body organs like livers and kidneys, provide insulation and thermoregulation against cold. So the subcutaneous fat in infants or neonates provides them insulation, and same is the case with the adults as well. We get insulation and thermoregulation against cold due to this insulatory layer of fat dust under our skin. Provides essential fatty acids, which helps in growth, promotion, and maintenance of skin integrity. Skin needs fat for its integrity. Fatty acids are the main source of energy for cardiac muscle cells. Yeah, cardiac muscles, unlike brain cells, cardiac muscle cells use 70% or more as a source of energy, the fatty acids. So that is why the aerobics or cardio exercises reduce your weight drastically. If you are doing some exercise in which your heart pumps uh, strongly, and if your heart rate becomes fast, if you're doing aerobics, if you're doing cardio, your cardiac muscles are using the fatty acids. So the fat reserves of the body get tapped upon. And if you have good fat reserves, it will take 6 months or 1 year for the exhaustive routine to continue, but eventually you will lose all the accumulated fat in your body. And which organ will be using your fat? These cardiac muscle cells. The protective function, fat deposited around organs acts as a cushion and protects from injury as well. Vitamin absorption, certain vitamins, namely vitamin A, D, E, and K are only fat soluble and need fat to be absorbed from the intestine. Then there is synthesis of steroid hormones. Fats are necessary for the synthesis of steroid hormones such as estrogen, progesterone, testosterone, which are important for the reproductive function. The hormones of the adrenal glands, such as cortisol and aldosterone, which are very important functions, also need fat for their synthesis. Then we come to the fourth essential nutrient, and that is vitamins. Vitamins are organic compounds that our bodies use in very small amounts for a variety of metabolic processes. Basically, they keep us healthy and help our bodies to function properly. We get vitamins from the foods we eat. For most of us, a healthy and varied diet that includes all 5 food groups is all we need to stay healthy. It is best to get vitamins from eating a variety of healthy, unrefined foods. Why unrefined foods? We will discuss later. So the classification of vitamins is very simple. It's not some complex classification. Vitamins can classify as fat soluble vitamins and water soluble vitamins. And fat soluble vitamins are vitamin A, vitamin D, vitamin E, and vitamin K. Vitamin K is also called phyloquinone or anandinone, and vitamin E is also called tocopherol. Vitamin A is also called retinol or retinoic acid as well. Vitamin D is also called whole calciferol. So these are fat soluble vitamins. Then there are water soluble vitamins such as vitamin B1. We discussed about the significance of vitamin B1 at the start of our lecture, and we discussed about the alcoholic uh, alcoholic people coming to the hospital with the deficiency of vitamin B1. Then there's vitamin B2, also called riboflavin. Then there is vitamin B3, also called niacin. Then there is vitamin B5, pantothenic acid, vitamin B6, pyridoxine. Vitamin B6 pyridoxine is also very important for our vision. Then there is vitamin B7, also called biotin, vitamin B9. Vitamin B9 is basically folic acid. And vitamin B12 is cyanocobalamin or cobalamin. And then there is vitamin C, which is ascorbic acid. All of these are water-soluble vitamins, contrast to the fat-soluble vitamins, which are vitamin A, D, E, and K. So we will discuss, we cannot go into the details. That's why I added the tables to cover all of these vitamins in a single slide. Vitamins, fat soluble vitamins play a very important role in our bodies. Some of their most important functions, along with sources and other names, are listed in the table. I added this table. This table has been obtained from Field Fresh Nutrition, a very important table. So, fat soluble vitamins, vitamin A, D, E, and K, differ from water soluble vitamins. They are insoluble in water, gastric external juices. Fat soluble vitamins require bile for their digestion. They do not get digested directly. If there is no bile coming from the liver through gallbladder and the uh, uh, pancreatic duct or the common bile duct, you cannot digest fat soluble vitamins.
Dr. Omer,
That
we
is
have
why.
about 5 minutes to go.
Oh my
Unfortunately.
God. I
Yes.
tried my best to cover it, but it's okay, okay. I will cover a bit faster. So fat soluble vitamins require bile for their digestion, and so I will not go into the story of bile right now because it will take another 5 minutes. Okay, fat soluble vitamins are stored primarily in the liver and fat cells. Yeah. They are stored primarily in the liver and fat cells. The fat soluble vitamins participate in numerous activity throughout the body. I will just discuss their functions. I will not go into other details. You people can read this later. So vitamin A is needed for vision and skin regeneration. Vitamin D is important for bone mineralization. Vitamin E is a very strong antioxidant. It stabilizes many cell membranes. So it is a very important oxidant. It also helps the germ cells of male and females. So it also increases the fertility of the people. Vitamin K is a very important vitamin. It helps in the synthesis of blood clotting proteins and bone proteins. The food sources are shown here. I will not go into the details. You can read this later. Then there are water-soluble vitamins. Water-soluble vitamins are also essential nutrients which play many important roles in our body. Their RDA, recommended dietary allowance, is called RDA. Sources and functions are described in the table. Basically, the best sources and functions of all these vitamins are written here. I will not read this whole table. You can read this table later, but this is a very important table I stumbled upon while researching for this lecture. So you people should read this table. Then there are minerals. I love minerals. So in the context of nutrition, a mineral is a chemical element. So they are not organic substances, they're basically inorganic elements. Some minerals are essential for life, many are not. Minerals are one of the five groups of essential nutrients. The five major minerals in human body are calcium, phosphorus, potassium, sodium, and magnesium. These are five major minerals which we need in a relatively larger quantity. Although minerals are micronutrients, they are not macronutrients. We do not need them in grams. But if we compare the minerals with each other, then there are five major minerals in human body, such as calcium, phosphorus, potassium, sodium, and magnesium, which we need in grams. And then there are other minerals which are trace elements. So basically, there are some major minerals which we need in milligrams as well. But then there are other nutrients which are called trace elements, which are mostly needed in milligrams or less than milligrams, such as micrograms, such as iodine, selenium, copper, zinc, etc. So there is a very good table I stumbled upon while researching. So you need to read this table as well. I cannot read this table due to the shortage of time. I had too many things to add, but I had to skip many other important things. We will discuss the all of the deficiency effects, all of the mineral related disorders, all of the vitamin related disorders in detail when we go to the topic of nutrition and its impact on the health of human beings. And when we will discuss the basic topic of nutrition and health related problems related to nutrition, then we will discuss this table as well. So what are the deficiency effects of these nutrients, these minerals, and what are the toxicity effects we take these minerals if we start taking these minerals in excess quantities? Then there is the concept of balanced diet. So balanced diet is an important part of maintaining good health and can help you feel your best. This means eating a wide variety of foods in the right proportion and consuming the right amount of food and drink to achieve and maintain a healthy body weight. Or a balanced diet is one that provides the body with all the essential nutrients in optimal proportion required to maintain cells, tissues, and organs as well as to function correctly. So basically, we need all of these seven groups of nutrients: water, vitamins, minerals, carbohydrates, fats, etc. We need everything, but in true optimal proportions. We cannot start taking solely carbohydrates or some sort of minerals and not others. We cannot do this. That will not be a balanced diet. That will be a malnourished diet. So the components of balanced diet are the same that we discussed in the start of our lecture. These are carbohydrates, proteins, lipids, vitamins, minerals, water, and fiber. Yeah, fiber. Although the fiber component of food has no nutritional value, but still it is considered extremely important component of our food. Fiber or roughage is non-digestible carbohydrate, and it has an important role in aiding the movement of food through the gut. So basically, there used to be a classification where they used to say there are six components of balanced diet. There are six components of balanced diet, but now modern day nutritionists and modern day books is the seventh component. So there is an eat well guide. I strongly wanted to go into the details of this very important image. So I will just shortly touch the details of it. The the pie square chart that they have made shows us the amount or the proportions of food that we should take. So basically, the major component of our diet should contain fruits and vegetables and whole grains or cereals, not some refined food. We should not take refined foods. We should take raw fruits and vegetables. We should take potatoes, bread, rice, pasta, and other starchy carbohydrates. And we should take whole grain materials. We should also contain dairy. We should also take dairy and alternatives in relatively smaller quantities. And we should also take beans, pulses, fish, egg, meat, and other proteins in uh, uh, mm, 25% of the quantity of our food. But this eat well guide is very, very important to remember, not for this class, but for day-to-day living as well. You need to understand the concept of eat well. The fruits and vegetables, you need to eat at least 5% of variety of fruits and vegetables every day. And you eat more beans, you need to eat more beans and pulses as well, but 2 portions of sustainably sourced fish per week, and one of which is oily. Eat less red and processed meat. You need to eat red meat as well, but if you have a sedentary lifestyle, then you need to have a little bit less quantity of beef or other red meats. Then you also need to drink milk, but you have to have a portion of your diet confined to the milk, and not whole of your diet should contain the milk products. This is a very important image. You should remember this image. You should go into the details of this image. There is, then check the label on the packaged foods as well. There is then information about how to understand the label. The last slide for today's class is relationship between good nutrition and health achievement. Although we will discuss the relationship between good nutrition and health in our next class, but I had to touch it in this class, and I skipped the malnutrition aspect of nutrition in today's class. We will discuss the concept of malnutrition and the problems related with the malnutrition later on. So the relationship between good nutrition and health is achievement of optimal growth and development, reflecting the full expression of one's genetic potential, maintenance of the structural integrity and functional efficiency of the body tissues, necessary of for an active and productive use, mental well-being, ability to withstand the inevitable process of aging with minimal disability and functional impairment, ability to combat diseases. If some person is having a very good balanced diet, he can combat diseases very well as compared to the person who's having a very poor diet. So if a person is having a very good balanced diet, he or she can resist infections on its own. That is called immunocompetence. Then preventing the onset of degenerative diseases. There are many degenerative diseases that have the link with the vitamins or mineral deficiencies in our body. So all of these degenerative, many of these, not all of them, there are many other related with the genetics as well, but there are other degenerative diseases which can be prevented by giving the essential vitamins and minerals as well. Then there is the resisting the effect of environmental toxin and pollutants, so those people can resist the effects of environmental toxin and pollutants who are having a good nutrition. Have a nice day. Thank you. Any questions?
Dr. Omer Farooq Khan. Ladies and gentlemen, I thank each and every one of you as usual for your attendance. Very, very unfortunately today, we are 10 minutes past the time that we had for this session, and we're not going to have time for questions at all. I apologize very deeply about that, but
I am willing to answer questions for even half an hour if you allow, because my
what
students
happens
love to question
I
me.
know, I know, I know. But what happens is, we have some accommodation for some other things, and it's a very, very sad thing. We all understand that, Omer, that your presentation was really outstanding. As usual, you performed very, very well, and today was not an exception. What we get from you is the types of things that we
Thank
need
you.
for our entire life. It's not just from an academic standpoint, but
Yeah, yeah.
we're talking
It's not
about the
just an academic thing.
essentials of life. I remember that very, very critical statement of yours. We are what we eat. It's very important, ladies and gentlemen, my very beloved attendees, that you all remember that sometimes you stumble upon foods that you want to eat,
Okay, if
but
any of you, sir, can I say one thing?
yes, yes, doctor.
Yeah, if any of you is having any question regarding today's lecture, I will request Dr. Galtin or whoever schedules our next class, and our next class is scheduled in the month of June, I think at the end of June. So I will cover the second lecture of the nutrition series. So if any of you is having any question that I am unable to answer today, we will try to accommodate your answers in at the end of our next class as well. So I will give a half an hour extra. I never shy away from giving answers to the questions of my students, no matter how long does it take. So I'm always willing. So that I can do. I can do from my part. I will answer the questions from today as well in at the end of our next lecture, because this is a series. This is not just a topic for today. The nutrition, you can write 2,000-page books upon nutrition, so I
Yes.
cannot do justice in single lecture. It's just a basics. It's just a rapport building with the topic. We have to cover the basics of what I have to teach, the nutritional aspect of what we are eating, then the nutritional disorders and their impact on human health. Basically, that is our topic. So we are going to move towards basic purpose of today's lecture in our next lecture.